Welcome to the demonstration describing how to add scenarios to the model using the new BOSfluids interface. Adding in a scenario to the model allows us to change input parameters of the piping system to quickly evaluate and examine different transient scenarios in a very efficient way. This demonstration describes how to create a scenario and the available options and limitations in using this feature. For this demonstration, we will use the hammer model found in the standard model folder in the BOSfluid install directory. In the hammer example, a long pipeline experiences waterhammer effect by the rapid closure of a valve. To begin, we will add a new scenario where the valve closure time is increased. Select Tools, Scenarios to introduce a new scenario. The scenario window appears, displaying all the current scenarios in the model. Click the Add icon to introduce a new scenario. Enter the name of the scenario and the brief description and click OK. The user interface of BOSfluids input area has changed to include the new scenario, displaying the main model and the added scenario. When cycling between the two scenarios, we see that the scenario view appears in the edit mode. In the edit mode, we can change the input parameters and element type as we wish. However, we can't introduce extra elements or change the physical length of the model. Let us increase the valve closure time in scenario 1 to close the valve in 2 seconds. In running the simulation, both scenarios are listed. Ensure that both the main and scenario 1 are selected and run the simulation. When we proceed to the Results tab, we can see that the results of both simulations can be viewed. Let us return to the main model and increase the discharge coefficient of the valve from 0.1 to 0.3. Changes made in the main model will propagate through to all scenarios. Let us introduce a second scenario with the relief valve introduced in the system at node 26. Since we can't introduce an extra element in a scenario case, we need to introduce the element in the main model. Setting the element type to none will tell the solver to ignore the element. Go to scenario 2 and introduce the relief valve and appropriate boundary conditions. Run the simulation. Again, we can see the results for the main model and the two scenarios. If we are interested to see the opening position of the relief valve for scenario 2, we go to the 2D output area. We have not given the relief valve a name, however we can still view the opening by entering the two node positions of the valve. This completes the demonstration on using scenarios in BOSfluids. You can view other features of BOSfluids on the DRG YouTube channel.